Okay, well, let's see how this works. So we are starting on lesson 16, which I believe is on page 88. Pretty simple lesson, graphing quadratics from the vertex form. So it's probably a form you're not familiar with, but it can tell us a lot about a graph of a parabola and specifically the vertex, which is why it's called vertex form. So we are going to ignore the opening exercise to begin with. And we're going to go down to look at the exercises. So you will notice in 1a, that equation is in vertex form. So the reason it's called vertex form is because when we have the equation the vertex in this equation are the values for h is the x value, the value for k is your y value, and that coordinate ordered pair is your vertex. The most often confused portion is this x minus h in parentheses. The h is the number there. The sign does not stay with it. So in this first example, the x coordinate would be 5, and the y coordinate would be 3, and that is the vertex of that parabola. In the second one, it's not technically in vertex form, or it doesn't appear to be so. But if you want to think that it's truly x minus 0 squared minus 2.5, then it looks more familiar in that form. And my vertex for the second one would be 0, negative 2.5. So the difference there with the y value is that the sign stays with the number. In this third example, I don't have a k value, so you can think of it as plus 0. Because for the vertex, I do need an ordered pair. I have x plus 4. So the way that changed from x minus h would have to mean that that h value would be negative. So I'd have a vertex of negative 4, 0. So what's really happening in this one, inside that parentheses, is x minus negative 4 squared. And that gets me the x plus 4. So that h value is counterintuitive. So a lot of people tend to think that it's the opposite of what's in parentheses. So I have negative 5 there. The opposite of that is 5. That's my x value. I have positive 4 here. The opposite of that is negative 4. So that's my x value. The y value is always going to be this k value outside. Whatever sign it is the sign of that. Moving on, given a vertex, now we can write an equation. The a value does not affect the vertex whatsoever. And we'll talk about the a value in a little bit. So my equation means I have to have y equals. Doesn't tell me I have to write an a value, so I'm not going to at this point. I have x minus h, which is the x coordinate, squared, plus k, which is negative 4. So that is the vertex form for the parabola. with a vertex 1.9, comma negative 4. Second one, x minus 0. So you can write it like that, or we already saw it's just going to be x squared. And then this is positive 100 plus 100. And the last one, I'll do in 2 steps so you can just see it. X minus negative 2 squared plus 3/2. So when I simplify that, x minus negative 2 becomes x plus 4. No, it doesn't. It becomes x plus 2. Squared plus 3/2. So far, pretty easy. We're just plugging in numbers to find the equation. We're looking at the equation and finding the vertex from those numbers. So the exploratory challenge we're going to go through together. So Caitlin's got 60 feet of material, making a fence, wants to create a rectangular pen for her dogs to play in. What would the dimensions that maximize the area? So the things we know is that we're going to have W be the width, and that whatever the length is, try that again. My length is going to be 60 minus 2W, or as we can think of it, 30 minus W, because I have 2 lengths here and here, because it's a rectangle. My length is 30 minus W, my width is W. The perimeter has to be 60. So now we have to define a function that describes the area. Hopefully you will remember that the area is equivalent to the length times the width. So length times width, that is a function that describes my area. I want to rewrite that in vertex form. So I'm going to multiply. So I have 30W minus W squared. And I got to write this in vertex form. So I have to complete the square. So I'm going to take out the negative 1. And then remember, I'm going to take half that middle term. So half of negative 30 is negative 15. Square it, becomes plus 225. 15 squared is 225. And then I can't just add a number randomly. So then I have to have a number out here. And this is also going to be plus 225. And now you're like, wait, I can't just add that. That's 450. But remember, what I'm doing is multiplying by this negative 1. So negative 1 makes that really a negative 225 that's being first put in there. So to counteract that, to keep it at 30w minus w squared, I have to add 225. Rewriting that in vertex form, I can write this as a factor product now of w minus 15. I'm just going to change the spacing on this. We'll go down to D. Just continue the process down. It's going to look better visually. W minus 15 squared plus 225, which leads us right into D. What are the coordinates of the vertex? Remember, this is x minus h, so the x value is 15. The y value is 225. And what this is telling us in terms of the problem is that when the width is 15, I get an area of 225. Now, if I think about this graphically, I know a parabola, kind of either a U or an N shape. This negative will determine which way it opens. So because it's negative, it's going to open down, which means the vertex up here, that 15, 225 point, is my maximum. It's the highest point on the graph. So the dimensions that will maximize, well, if the width is 15 and the length is 30 minus the width, 30 minus 15 is 15. So 15 by 15 is what will the dimensions be to get me my maximum area, which is 225. So everything ties in back together. So the reason I ask is, do you think this is a surprising answer? Is because, yes, it's a rectangle, but it's ideally a perfect rectangle or a square. So all the dimensions of the sides are the same. And what this parabola is representing is that any width on here will give me an area. So if I had a width of 2, I would have an area less than 225 because it would be 2 by 13. So I'd have an area of 26 square feet. So this is asking what is the maximum area given the fact that I only have 60 feet of material to work with. So if she builds a 15 by 15 pen, then her dogs will fit in.